My name is Jordan Welch, and I'm creating this lesson for a 3rd grade elementary school student. So this is the Walter Pyramid. It's located in Long Beach, California, and here's a real life photo of it. It is 345 feet all around the edges, on all 4 edges of the square, and it is approximately 18 stories tall. So here's my 3D model I created of it. My 3D model is 5 units on each side, and it is 3 units tall with a slant height of 3.9 units. Now, on this lesson, we're going to learn about surface area. So surface area is the measurement of an object's total outside space. So if we were going to look at the surface area of the store, we would calculate any part of the door that you can see or touch. So that all on the red would be the object's surface area. If we were going to look at the surface area of this ball, it would be anything, any part of the ball that you can touch for the surface area. Now, we can't confuse surface area with volume. Volume would also measure the inside space of the ball. However, for surface area, we're only measuring the outside spaces. Or, for example, this cube, you can measure the surface area by finding the surface for all 6, the area of all 6 squares. Now this is important because it has real life applications. For example, if we were going to paint or measure or put frosting on this cake, we would first measure the surface area of the cake to determine how much frosting we would need to buy in order to cover the cake completely. Or if we were going to paint this house, for example, we would find the surface area of the house which needs to be painted. Then we can determine how much paint we need to buy in order to properly fill every square inch of this house. Now we can take a look back at our model of the Walter Pyramid. So we can take this pink marker here and find the amount of edges this pyramid has. So it has 1 edge here, 1 edge here, 1 edge here, 1 edge here. There's 4 edges. Here's another edge. 5, 6, 7, 8. So this pyramid has 8 edges. Now we can find the amount of vertices this pyramid has, which is points on this pyramid. There's a point here, 2 here, 3 here, 4 here, and 5 here, for a total of 5 vertices. And next, we can find the amount of faces on this. So there's 1 face here, which is the base. There's another side here, 2. There's a back face, 3. The side face, 4. And the front triangular face, 5. So there are 5 faces. Now, based upon the lateral faces of this polyhedron, which are the faces that aren't the base, so 2, 3, 4, and 5, they're all triangular faces. So based upon the lateral faces, it would be a triangular pyramid. However, we're going to look at the bottom base, which is a square. Looking at the square base, this would be a right regular pyramid, which is the name of this figure. Now, to find the surface area of this figure, we can use this formula right here. Surface area equals 1/2 times P, where perimeter of the base stands for P. Now, L here is going to stand for the slant height, which is already given to us at 3.9 units. And B is going to be the area of the base. Now we need to find these components to plug them into our formula. So first we can find perimeter. Perimeter equals length plus width plus length plus width of the base, which is 5 units. So it's going to be 5 plus 5 plus 5 plus 5, which is going to be 20 units. Now we can find the area of the base, which is B. B equals length times width, which is 5 times 5, so it's going to be 25 units squared. Now we can plug these two variables into our equation. So surface area equals 1/2 times perimeter, which is 20 units, times the slant height, which is 3.9 units, plus the area of the base, which is 25 units squared. So if we plug this into our calculator, we would find that the surface area equals 64 units squared. So this means that 64 units covers our polyhedron. So it takes 64 units to cover the area on the outside of our polyhedron. Now next, we're going to find the volume. So the volume formula is 1/3 base times height. Now B stands for just base, and the H stands for the height, which we already have both the base and the height, so we're just going to plug it into the equation. Volume equals 1/3 times the base, which is again 25 units squared. So 25 units, and then times the height, which is what we already know to be 3 units. Now when we plug this into our calculator, 1/3 times 25 units squared times 3 units, our volume is going to equal 25 units cubed. Meaning, there's 25 units in our polyhedron. So this is our lesson on surface area and volume for our right regular pyramid.